Today we're going to introduce laboratory safety in the elementary school. So the most important thing is to make sure that you take time to plan. The way that might look is becoming familiar with the procedures and any substances that you're going to be using in your classroom. You should always perform the activities and experiments before assigning them to the students. This will really help you with identifying any safety concerns, any alternatives that you might have to using something dangerous. But also it'll help you work out any problems. That way when the students come in, there's no frustration over trying to problem shoot with the students all looking at you and waiting for you. And you should only follow reputable published procedures when mixing or using chemicals. But if you're practicing these things before you're starting them, then you really shouldn't have the issue of improper mixing or incompatible chemicals. So what might the planning process include? Well, one, you'll need to identify materials needed, how you will distribute them, identify safety issues and plan how you will address them, consider how you will instruct your students, consider possible emergencies and how you will handle them, ensure that the necessary safety equipment and supplies are available and nearby, and also make sure you know how to use them, because a fire extinguisher is great until you don't know how to use it, and then it's just a useless fire extinguisher. Plan how you will collect materials and safely dispose of the waste. Plan for students to wash their hands when the activity or experiment is complete. So the last part is kind of the important wrapping it up. How will you make sure that the students have washed their hands? So let's kind of go through this step-by-step process. Materials. Most elementary science activities will call for household chemicals, things you can buy at Walmart, Target, not chemicals that you have to buy from a special supplier. But even though these are things you buy at Walmart, you buy at Target, and therefore they seem safe because they're in our households, these household chemicals are still poisons. They are still incompatible with other substances, and they could still hurt somebody if they're breathed in through the nose, if they get exposed to the mouth, the eyes, the skin. So one of the things you need to do is study all of the product labels and carefully make sure you understand any hazards and warnings with those household chemicals. If a chemical is purchased for an activity from a science supply company, it should come with what's called an MSDS sheet, which is a material safety and data sheet. We're going to look at a material data safety sheet with our activity when we take the break, just a part of the way through this lecture. Make sure you know the hazards along with how to properly store and dispose of all of the chemicals that you have. You should always store chemicals and any solutions that you make in a properly labeled container intended specifically for chemical storage. So glass bottles, plastic bottles, they can all be purchased from a chemical supply company, or you can even buy them off Amazon. But you should never, ever, ever use an old food container for chemical storage. So don't take a bottle of water and put bleach in it. I know that seems pretty straightforward, but even if you label that bottle with the word bleach on it, it still is obviously a water bottle, and there can be confusion because bleach looks a lot like water until you smell it or drink it or get it on your skin. The last one is a kind of a special item. It's to store dry ice. These are things you can buy at Kroger, Walmart, but you should store it in a container that can vent. So an ice cooler or a cardboard box is a great idea. If you store dry ice in a container that's super sealed, like those Yeti coolers that are super locked down, it could actually cause an explosion from the buildup of the carbon dioxide gas. So you can still store them in your freezers. They are not going to explode in your freezer because that, believe it or not, is vented. They're just regular old styrofoam ice chest or in a cardboard box, but don't put it in something that cannot ventilate into the room. When you're looking at how you're going to distribute your materials, these are just some examples of ways in which it might be useful, depending on the age group that you're working with, to distribute. So here, this is like an appetizer tray on the left. They have the Q-tips in the bowl, the different dye. And what this is milk and food dye. And so they pour milk in there. They take a little bit of soap and put it on a Q-tip. And you put a few drops of dye in the milk. And when you touch the Q-tip to the dye, it spreads. It's hydrophobic. Water fearing, water loving repulsions. Kids love this experiment, and this is a really great arrangement that would allow 5 different kids to work side by side, maybe around a small table. And these appetizer trays, you can find them on Amazon. I've found them at Party City supply stores. They're a couple, maybe $6 to $10 a piece. But the thing is, you can reuse them. And so if you buy them once, you can reuse them multiple times, and you can probably use them for different things. The second thing here is using, it's called walking water or walking colored water. And so there's test tubes all lined up. And the nice thing about this test tube holder is it's stable. It's plastic, it's durable, it's flat. There's no weird like feet or anything that could knock it over. And the way the test tubes are in there, they're very low profiles. So this is perfect for kids. The last one is making colored snow. And so this is almost like a tray where you would have paints in them if you were doing painting, and but they have different colored waters as well as sugar that they're sprinkling onto the colored. So this would be a great way of organizing your experiments. These are things to think about before you do them. See how practical it is when you do have them arranged, and try to figure out any issues with your distribution. Now, the goals of lab safety, we have kind of 4 main goals. The first goal is to gain awareness, this is for you, of potential lab safety hazards. So you need to practice the experiment so that you can become aware of things that might potentially pose a safety risk during the actual lab. The second one is to identify alternatives which would minimize any risks that you might encounter. The third is to prevent accidents and injuries. The fourth is to then teach the students the importance of lab safety. The more that you teach them, the more that they are not having to be taught by you every single time you repeat an experiment with a specific chemical or a specific piece of equipment, but you are still in charge of all of the lab safety, but teaching them is really the long-term goal so that they understand. So if we're looking at these 2 images here, we have 2 young ladies working on what looks like kind of an elephant toothpaste type experiment. They both have goggles on. Their hair is both pulled back away from their face. It looks great. When we're looking at this image right here, this is a common mistake. This young man has gloves and glasses on, but yet the young lady to his left and the young man to his right don't have goggles and they don't have gloves on. And to think that they're protected just because they're not holding the test tube, well, that's a common mistake. They are likely to be hurt, just like this young man is here, but they don't have the proper protection to protect themselves should that test tube fall, spill. It should get, if it got hot and exploded for any reason. And not to mention they're around all of these open containers that have chemicals, probably colored water for this image. But these are things we need to make sure we're aware of. When you're looking around the room, is the safety of the student ensured at all times? Are they minimizing the risks by doing the things that you're asking them to? So how can we become aware of safety issues? Some of them are going to be things we know. Don't put stuff in your mouth. Don't pick up broken glassware. Don't touch hot glassware. But one of the ways you can become aware of safety issues with things you're not familiar with is by consulting the MSDS. And you should always have it handy, meaning in less than 5 minutes, could you find the MSDS for the chemical that you're using that day? Normally these are stored in like binders. They should be in your classroom. They should be in your head teacher's classroom. They should be in the front office. And the reason why is if a student is injured, you're going to send the MSDS with the student to seek medical advice. If it's ingested, if it's skin contact in the eye, there are going to be recommendations in the MSDS how to treat it right now. And then you'll send that MSDS with the student to seek medical advice, because what happens is if a student goes to a doctor and their parent doesn't know what they've been exposed to, and they say they were exposed to something super dangerous like cyanide gas or hydrofluoric acid, when it really wasn't something that dangerous. They could be treating the wrong chemical exposure, or they could be doing something higher up than what they should be. Maybe we just need to monitor it for a rash instead of thinking that our skin is going to start falling off. So you're going to send the MSDS. Then you'll make a new copy when you send out the one you have. And you should always have copies in multiple places. So this says classroom, other places on and off campus. So sometimes an administration building will keep all of these records for safety concerns in a central location. When you're outside on a field trip, be prepared to instruct students on hazardous plants such as poison ivy. Out here, there is a lot of poison ivy in places where maybe there's not as much development, so it might be more concerning in an undeveloped place rather than something like the zoo, where they do a good job of keeping those places pretty clear of poisonous plants, but it's something to be aware of. Students should handle animals in the classroom voluntarily. Don't make a child hold a live animal, and only under close supervision. So never leave children alone with a class pet. And then don't make them hold it, because if you make them hold an animal and they're uncomfortable, they could drop it, they could hurt it, they could hurt themselves, and we don't want that to happen. And the last thing on here is to store your batteries with one terminal covered with tape. And so you'll just take a piece of tape one side of the battery, and this will keep the battery hopefully from corroding as it's stored, because batteries are chemical reactions and they're going to react as they're sitting in a drawer, and we want to prevent that as much as possible. The next thing is to identify alternatives. We're going to keep the use of glassware to a minimum by only using it when we absolutely have to, meaning we're going to use plastic beakers, plastic graduated cylinders, things that are made out of plastic, maybe metal, but we're going to avoid glassware if we can. It's hard to avoid glassware when we have to heat something up. So when you heat something up, you have a safety issue already there, and that's that the glassware could break. Carefully consider if sharp tools, whether these are knives, scalpels, wires, and needles, are really needed. If possible, maybe you can pre-cut materials or instruct students on the proper use of cutting tools, but if you can avoid them altogether, that's really the best practice in the classroom. One of the things that is becoming more and more common is that we're getting rid of mercury thermometers in all schools. At ETBU, we do not have mercury thermometers in any of our labs because of the hazard that mercury poses, and so we have what we call alcohol thermometers. They're a little bit low risk if the thermometer should break, and you want to make sure that you're always using alcohol thermometers in the classroom and never a mercury thermometer. To minimize environmental impact, you could also consider using rechargeable batteries. So instead of taking those batteries that you then have to throw away or dispose of, rechargeable batteries, though they do have to be charged, and that can be a little bit of a pain, it's a really good alternative to make for the environment, especially if you're in a classroom that's using batteries quite a bit. And batteries are pretty expensive. All right, so we're going to take a break, and we're going to review an MSDS in the next video, and you're going to practice, and then we're going to come back and talk about preventing injuries in the classroom.